5. Sensor programming in App Inventor. Central idea. What are the sensors? Different types of sensor. Developing an app using proximity sensor. When you point your mobile at the sky and Google Sky Map reveals to you which stars you're looking at. Tilt your phone and you can control the game you are playing. Take your mobile on your daily run and an application can record your course. All of these apps are possible because of the mobile devices we carry. Have a high-tech sensors for detecting our location, orientation and acceleration. Most Android-controlled gadgets have inherent sensors that measure movement, direction and different natural conditions. These sensors are capable of providing raw data with high precision and accuracy and are useful if you want to monitor three-dimensional device movement or positioning or to monitor the changes in ambient environment near a device. For example, a weather application might use a device's temperature sensor and humidity sensor to calculate and report the dew point. We can make apps in MIT App Inventor. Let's revisit the components of the App Inventor window. App architecture of App Inventor. Palette. Choose components. Viewer. Arrange components. Components list. Hierarchical view. Properties. Change component settings. Sensor and its types. Accelerometer sensor. Non-visible component that can detect shaking and measure acceleration approximately in 3 dimensions using SI units. M by S2. Barcode scanner. Component is used to read a barcode. Clock. Non-visible component that provides the instant in time using the internal clock on the phone. It can be a fire timer at regular set intervals and perform time calculations, manipulations, and conversions. Gyroscope sensor. Non-visible component that can measure angular velocity in 3 dimensions in units of degrees per second. Location sensor. Non-visible component providing location information including longitude, latitude, altitude, if supported by the device, speed, if supported by the device, and address. This can also perform geocoding, converting a given address, not necessarily the current one, to a latitude, with the latitude from address method, and a longitude, with the longitude from address method. Orientation sensor. Use an orientation sensor component to determine the phone's spatial orientation. Pedometer. A component that acts like a pedometer. It senses motion via the accelerometer and attempts to determine if a step has been taken using a configurable stride length. It can estimate the distance traveled as well. Proximity sensor. A sensor component that can measure the proximity of an object in centimeter to the view screen of a device. This sensor is typically used to determine whether a handset is being held up to a person's ear. That is, it lets you determine how far away is an object from a device. Many devices resend the absolute distance in centimeter, but some do resend only near or far values. Project. Let's create an app in App Inventor to play a beep sound when the mobile detects an object in front of it. Step 1. Open any web browser and type http://appinventor.mit.edu. Step 2. Click on Create Apps. Note: use an existing Gmail account or school-based Google account to log into ai2.mit.edu appinventor.mit.edu. To set up a brand new Gmail account, go to accounts.google.com/signup. Step 3. Sign in any of your Gmail account. Step 4. Type the name of the project in project name text box. Step 5. Click OK. Note, project name can only contain letters, numbers, and underscores. Now we will design the interface of our app. Step 6. Select Layout from the palette. Step 7. Click on Table Arrangement and drag to the viewer. Step 8. From the user interface, drag to button control on the screen 1. Step 9. Drag sound control from the media palette on screen 1. Step 10. Drag proximity sensor from the sensors palette on screen 1. Sound and proximity sensor are non-visible components, therefore they are not visible on screen 1. We can modify or change the properties of the visible or non-visible components from the Properties section. Step 11. Select Button 1 from Components. Step 12. Modify the properties from the Properties window. Change background color to green, font size to 30%, height to 30%, width to 70%, and text to Start. Step 13. Select Button 2 from Components. Step 14. Modify the properties from the Properties window. Change background color to red, font size to 30%, height to 30%, width to 70%, and text to Stop. We will change the name of the buttons so that it is easy to program the application. Step 15. Rename button 1 with Start and button 2 with Stop. Now we will add sound to our app. Step 16. Select Sound 1, Components. Step 17. Select Source. Click on Upload File to upload sound file from the computer. Step 18. Click Choose File and upload the file and click on OK. As we have finished our designing the tab, now we will code our app. Step 19. Click Blocks to add the coding. Step 20. Select Start. Step 21. Drag the When Start, Click Do block in the workplace. Step 22. Select Proximity Sensor 1. Step 23. Drag the Set Proximity Sensor 1 to Block to Workspace. Step 24. Select Logic. Step 25. Drag True to the workspace. Tip: drag the unused blocks to the trash to delete them in Blocks Editor. Step 26. Select Stop button. Step 27. Select When Stop Click Do block to the workspace. Step 28. Select Proximity Sensor 1. Step 29. Drag the Set Proximity Sensor 1 Enabled to block to the workspace. Step 30. Select Logic. Step 31. Drag the False block to the workspace. Step 32. Select Sound 1. Step 33. Click and drag the Call Sound 1 Stop block to the workspace. Step 34. Select Proximity Sensor 1. Step 35. Click and drag the When Proximity Sensor 1 Proximity Changed block to the workspace. Step 36. Select Control. Step 37. Drag the If Then block to the workspace. Step 38. Click on the violet symbol and select Else and drop it inside it block. Step 39. Select the Equality block from Math and drag it to the workspace. Step 40. Drag the Get block available in Variables and drag it to the workspace. Step 41. Select Distance from the drop-down. Step 42. Drag the 0 block available in Math to the workspace. Change the value to 10. Step 43. Select the drop-down and select less than, equal to. Step 44. Select the Call Sound 1, Play and Call Sound 1, Stop available in Sound 1 and drag it in If and Else block respectively. Step 45. Select Screen 1. Step 46. Select When Screen 1, back pressed, Do block and drag it to the workspace. Step 47. Select the Set Proximity Sensor 1 enabled block available in Proximity Sensor 1 to the workspace. Step 48. Drag the false block available in Logic to the workspace. Now, as our coding is finished, the app is ready for testing. Connect your app with your mobile phone as we have to test this app on the mobile only. Step 49. Select AI Companion from the Connect menu. Step 50. Select Scan QR Code in the MIT App Inventor 2 companion window. Step 51. Click on Scan QR Code. Bring the phone in front of the computer screen to scan the QR code and wait for some time. Step 52. App opens in the phone. Click on the Start button and bring the phone near different types of objects and hear the beep sound. Open the MIT AI 2 companion on your mobile. So we have created an app that plays the beep sound when the phone is brought near any object. Also, the Start button starts the app and Stop button stops the app.